In this video, we're going to talk about the side-side-side criterion for similar triangles. Remember that two similar triangles have the lengths of their corresponding sides in the same ratio, and their corresponding angles are equal. However, to prove that two triangles are similar, it's not actually necessary to check all this information. In fact, it just suffices to check that the lengths of corresponding sides have the same ratio. And this is what is known as the side-side-side criterion. So the side-side-side criterion states precisely that two triangles are similar if the ratios of the lengths of their corresponding sides are equal. Now, why don't we go ahead and apply this criterion to a few concrete examples. We want to determine whether each of the triangles below is similar, and here we've got our first pair of triangles, this small triangle with side lengths 3, 5, and 6, and this bigger triangle with side lengths 12, 20, and 24. So according to the side-side-side criterion, all we have to do is check whether the ratios of the lengths of their corresponding sides are equal. So let's get to it. Let's first figure out what the ratio is between the smallest sides in the triangles, the small side 3 and the small side 12. And the ratio there is just 12 divided by 3, which is equal to 4. Alright, so now let's check the medium sides. The middle side 5 and the middle side 20 here. So 20 over 5, that is also equal to 4. So far the ratios match up, but we still have one more pair of sides to check. The largest sides, 6 and 24. So let's go ahead and take that ratio. 24 over 6. Hey, that's also equal to 4. So now, since these ratios are all equal, we can conclude by the side-side-side criterion that the triangles are similar. So, yes, similar. Okay, let's jump into the next example. So again, we've got two triangles, a small one and a big one, and we just want to take the ratios. Let's start off with the smallest side, 2 and 6 in these triangles. The ratio 6 over 2 is equal to 3. And how about let's check the middle sides, so 3 and 9. The ratio 9 to 3, hey, that's also equal to 3. So far so good, but again we have one more pair to check. That's the largest sides in each triangle. So the ratio of 11 to 4. And unfortunately that is not equal to 3. If we write this as a mixed number, it's just 2 and 3/4. So that's not 3, which means these ratios are not all equal. So by the side-side-side criterion, we conclude that no, these triangles are not similar. Here's our next problem. Triangle ABC is similar to triangle DEF, and the perimeter of triangle ABC is 36. What are the side lengths of triangle ABC? Alright, so this is a bit of a trickier problem, but why don't we go ahead and start by writing an equation. When in doubt, write it out. Now, what kind of equation can we get from this problem? Well, they tell us that the perimeter of triangle ABC is 36, so we can set up an equation there. We can write that the perimeter equals 36, and then looking at triangle ABC here, the perimeter is just the sum of the side lengths, so really just the length AB plus the length BC plus the length AC is equal to 36. Okay, well, we don't know what AB or BC or AC are, but is there any information that can help us find them? What else are we told in the problem? Well, we're told that triangle ABC is similar to the triangle DEF. And we know from the side-side-side criterion that in order for these two triangles to be similar, all of the pairs of corresponding sides have to have the same ratio. Why don't we call that ratio r? And then we can set up an equation for each pair of corresponding sides. First of all, let's set up the equation for side AB. So r equals AB over the corresponding side in triangle DEF, which is DE. And let's do this for all of the other pairs of corresponding sides as well. So we also have that r is equal to the middle side BC over the middle side EF. And lastly, we have also that r is equal to the long side AC over the long side DF. And we know what DE, EF, and DF are, so let's go ahead and plug that in. So r equals AB over DE, which is 4, and r equals BC over EF, which is 6, and r equals AC over DF, which is 8. And now we finally see how we can solve this problem. The idea is that we'll solve for AB, BC, and AC in terms of r using these three equations. Then we'll substitute it into the perimeter equation and turn that into an equation of r. Once we solve that equation and figure out what r is, then we can go back to these three equations to figure out what AB, BC, and AC are. So let's continue forward. Solving this first equation, r equals AB over 4, for AB in terms of r, we just need to multiply both sides by 4. And we get that 4r is equal to AB. Same thing for this next equation. 6r is equal to BC. And then 8r is equal to AC. Now we can go ahead and substitute into the perimeter equation for AB, BC, and AC. So AB equals 4r, then BC is 6r, and then AC is 8r. And that sum is equal to 36. Adding all this up, we have 4r plus 6r is 10r, then plus 8r is 18r. So 18r is equal to 36. And that means r is equal to 36 over 18, which simplifies to just 2. Now that we have r, we can substitute back into these equations. Let's write down those equations again. AB is equal to 4r, BC is equal to 6r, and AC is equal to 8r. And then we can go ahead and substitute in for r into each of these equations. So AB is equal to 4r, which is just 4 times 2. So AB is equal to 8. Let's write that in the triangle. AB is equal to 8. And then BC is equal to 6r, so 6 times 2, which means BC is equal to 12. And lastly, AC is equal to 8r, so 8 times 2, which means that AC is equal to 16. And there we go. Here we have it. Here are the side lengths of triangle ABC. Now we know how to use the side-side-side criterion to solve problems involving similar triangles. This will be very helpful in the future when we solve geometry problems which contain triangles that may or may not be similar.